Welcome to Data Skeptic. Our mini episodes are gentle introductions to concepts related to artificial intelligence. These short discussions are meant to serve as a primer for the topic. Learn more by reading our show notes at dataskeptic.com.
Yoshi.
Oh, I can hear her.
What would we call this? On site? It's not on site.
We are in a car.
Yep.
Moving.
Up to 5.
Speeding, because Kyle's driving.
I'm driving perfectly safe. Highway speed limits do not correlate with safety.
That's another topic.
Yes, that's another topic. We are headed up to Skeptical, where I'm going to give a talk on Sunday. Or I will have given that talk by the time this airs.
We got Yoshi in the car.
Yeah. We had to fit in our time to record somewhere, and this long stretch of road seemed like a good way to do it.
So we're on the road.
So our topic today, Linda, is transfer learning. Transfer learning's come up a couple of times on the show, but we've never done a mini episode on it, so I thought it'd be appropriate. To begin with, I thought we could talk about how Yoshi learns.
Yeah.
Can you maybe share some experiences about how our lilac-crowned parrot learns things?
I'm not sure, but obviously with the vocals, she does repetition.
Yep.
But once we repeat, it's up to her whether she wants to pick it up or not.
Yeah, she says a number of phrases.
She's also a lazy learner.
Right. Well, let's talk about flying, though. Recently, we've let her wings grow out, and she's taken to flying quite a bit more.
So Kyle was the one who wanted her wings to grow out.
Yeah.
And just to take a step
clarify
back,
what that means for the
what does
number
it
of
mean
people.
when we clip her wings?
Right.
People think it's a muscle we clip. No.
No, it's not cruel.
Her feathers, which don't have any feeling in them, it's like cutting hair. You just trim 4 or 5 feathers on each side of her wing.
And only 4 or 5.
Yeah, and so she could still flap, flutter to the ground, but she won't take an upward lift.
Yeah.
So that's what it means when you trim a bird's wings. You're not cutting any muscle. It's not a permanent thing.
Yeah, it's just like half the feather.
People think that it's permanent. It's just like hair. So we all have to constantly trim her once a month or once every 2 months. Depends if she's molting.
2 months, I think.
Depends on her state of feathers.
Yep.
Anyways, so Kyle started getting sad because Yoshi couldn't fly.
Yeah.
And so Kyle would complain. And my perspective, just with some background, is I had a bird, Dandy, growing up. We had him for 20 years. And one day he got freaked out. And as birds do, they have a fight or flight mentality, and birds don't fight, obviously. So when they're scared, they fly. They just fly blindly. And daytime birds can't see at night. So it was nighttime. He flew out of his cage, out of the garage, which was open. It was nighttime, and he just flew like a madman, and we never found him. So we never, ever trimmed Dandy's wings. So that was very sad to lose a bird that way.
So we're very careful with Yoshi to make sure she can't get out. But she didn't really know how to fly exactly. I mean, she sort of naturally knew it, I guess, a little bit instinctively. But she had some rough beginnings, right?
I think birds were made to fly. She knew how to fly. Doesn't mean she was good at it.
Okay, maybe she knew how to fly. Did she know how to land?
She would land hard. One time, she hurt her foot. We had to bring her to the doctor. And the doctor gave us some numbing medicine for her because she would bite her foot because it was in pain.
But even in terms of where she wants to land, for a while she was kind of crash landing into that one pillow.
So yeah, we have a little armchair in the living room. So Yoshi figured out that it was soft. So now she kind of just tries to land there because it's soft. It's very cute.
That's where I sit to read papers off the archive. Anyway, how does she land now?
So Yoshi has been trained since a baby to step up, as in when we put her hand right where her chest level is, she just steps her 2 feet on our hand, and we could take her anywhere we want. It's a training thing that, it's good to train your bird this basic command to step up. That way you could take your bird places, and you could build trust, and you could build a relationship with your bird. So lately, I think Kyle was the one who first experienced it. Yoshi would just take off. And then as Kyle saw Yoshi flying towards him, he just stuck his hand out. And lo and behold, Yoshi would just naturally was like, well, what do I do with a hand? I just land on it. So she would kind of slow down and hover a little bit.
Yeah, at first she was very clumsy, right?
Well, I don't know about that. You tell me about that. I don't
Well,
know.
like the first time she landed on my hand, she just about flipped over, you know. I had to kind of like move forward to absorb some of the momentum.
Oh, yeah, one time I didn't know that we were supposed to absorb her momentum for her.
Yeah.
So I just reached out, as Kyle told me. She landed on my hand, and I didn't move my hand forward to catch her. She flipped upside down, and I was laughing so hard.
But now she's like a professional. She has this nice way she glides in, and she almost kind of slows down for the landing.
She's a little dainty bird.
Yeah, but all told, she didn't do that many flights before she got pretty good at it. How many times would you guess she landed on either of us?
I don't know. You're the one who have been around her more. How many times?
Maximum 10.
There you go.
Now, this is very contrary to how machine learning typically works. In machine learning, you got to provide lots and lots of examples. Depending on how noisy your data is and how complex the signal is you're trying to measure, you might need hundreds of thousands of examples, which is common in a lot of natural language processing applications. How is it Yoshi was able to learn with so few examples, do you think?
I think she's wired to fly. First of all, her body, her respiratory system, her feathers, and then just instinctively in her brain. Even if she didn't have a parent bird showing her to fly, you just push a bird off and the bird will fly.
So there's a number of factors going on here that we're kind of convoluting into one. She is pre-wired to fly in a lot of ways.
Just like we're pre-wired for language, right?
Well, sort of. That's a little different sort of an argument because we had to develop it. But yeah, we seem to have all the wetware that allows us to rapidly develop language, and it's rather natural. In this regard, the analogy starts to break down a little bit. But what's interesting is she was able to learn a good landing off very little training data. That's not something machine learning is traditionally good at. Now let's do another quick analogy. You used to play tennis, right?
Oh, yes, back in the day in high school.
How good did you get?
I wasn't very good. Technically, I was okay.
I bet you were great.
I was really bad at serving. That was my number one flaw. That and what else? Oh, yeah. Mentally, even though I would know I was technically better than the other person, I couldn't win a game. So mentally, not good.
Did you ever play badminton?
Yep.
Now, how well did knowing a little bit about tennis make it easier for you to learn badminton?
I thought badminton was easier, but that being said, it was just recreational badminton, not like I was being competitive about it.
Sure.
So obviously I'm not going to make it to the Olympics. So all you people out there who really know badminton, please don't take it as an insult.
Never say never. What's the other one? Wiffle ball? That's a real game, right?
Wiffle. Oh, yeah,
did you ever
yeah.
play that?
There's that means it's a bat and a plastic ball.
Oh, I was thinking it was some sort of a racket as well. But
No, it's a bat.
Okay, well, then it's not quite the same thing. But if you went to go start picking up wiffle ball, do you think any of your tennis skills would help you out a little bit?
Actually, I'm so glad you brought that up, Kyle, because now I could brag.
Yeah, let's do it.
One time, I can't remember, I think it was college, someone had a wiffle ball, and we were like, let's play a baseball game, but with the wiffle ball. So we had a pitcher, and everyone went up to bat, and everyone could not hit the ball on the first time. Some people, I don't even know if they actually hit it, I'm not sure. Me, with my tennis background, I hit the ball immediately, and I hit it good. I can't remember how far it went, but I had the best hit from everyone. And it's because in tennis, if you're hitting it properly, your ball should be in the sweet spot, which is it's in line with the stem. What's the stem of the racket called? The handle. In the middle, it should be aligned with that. That's the sweet spot. And in the middle of your racket, that's where most of the power and control is for tennis. If you're like me and you just went to tennis camp and hit the ball over and over again, it's pretty easy to find the sweet spot. It's just automatic. So you have the hand-eye coordination, and then you have the muscle memory. So it wasn't that hard for me to hit the sweet spot. And I was like, wow. I was like, for my tennis training, I was like, wow. I was like, maybe I should have played baseball.
Maybe.
But anyways, what was your question now?
Well, no, you were kind of proving my point there. So unlike certain things in data science that aren't named very well, transfer learning is named excellently because you can see where your skills from tennis transferred to wiffle ball, right? I'd like to thank Brilliant.org for their continued support of Data Skeptic. Have you checked out Brilliant yet? If not, today's the day. Brilliant.org/Data Skeptic will bring you directly to the problem of the week. It's a fun challenge that can help you stay sharp on your afternoon coffee break. Log back in when you're home from work and click on Courses at the top of the page to see the list of options they have available.
Brilliant's courses aren't boring lectures. They have this guided, interactive interface that seamlessly blends the teaching with practice. That's my personal favorite feature because that way I can switch between the computer in the recording studio, back my laptop in the house, or my tablet. Check out Physics of the Everyday or Artificial Neural Networks. Join millions of problem solvers on Brilliant today. Start your learning journey at brilliant.org/dataskeptic.
Transfer learning is named excellently because you can see where your skills from tennis transferred to wiffle ball, right? It's not the same problem you're solving, but you were ahead of the game because you had some other knowledge.
Yeah, sure.
And this goes on and on. Like, if you play the trumpet, it's rather easy to switch to the trombone. There's things to learn, but you got a head start. If you know something about measure theory, you're going to get good at universal inductive learning pretty fast. There's a lot of things where there's a similarity between two styles of problems you want to solve, and knowing something about one can help you learn about the other. So getting back to the fact that machine learning takes lots of examples, some very clever people started asking, well, what about in cases where we don't have a lot of examples? Can we learn in one domain and transfer it to another? So you might think of like medical image diagnosis, something we've been covering on the show quite a bit. In medical image analysis, they generally have a very small corpus of examples, right? Not that many people necessarily get a rare disease, so you don't have that many x-rays or biopsies or whatever. Your data can be a little sparse. Make sense? But what if, you could train an image recognition algorithm on some of the very widely available databases, CFAR, MNIST, that kind of stuff, and you build up a neural network that is able to learn pretty good on a general domain, and then you use that as a starting point to learn on the specific domain.
So you're training it on some set of data, even though it's not the data.
Yeah. And then you finish off your training with the potentially smaller but more applicable data set you've got.
Okay. This kind of mirrors some of your data training episodes.
Yeah. And maybe we could talk a little bit about the mechanics of how you do that. So in something like a deep neural network, which we've covered before, you might remember that it takes a bunch of inputs. Maybe those inputs are the pixel values of an image. It runs it through multiple layers where all these neurons, you've trained them to find the specialized weights that really solve the problem very well. And then at the last layer, you have some sort of way of selecting amongst those signals and coming out with a class label saying, this is a picture of a bicycle or a goat or whatever it may be. If you do all that same process, and then you just kind of cut the top layer off, or maybe you be strategic about where you cut it, but you just take part of that network, and then on top of it, you put a blank layer of the network, and you try and learn the new problem. So instead of initializing to random values like you do to learn a neural network from scratch, you basically initialize to the solution to some other problem. What do you think of that?
What does it mean to initialize?
In a neural network, and really in any machine learning approach, decision trees, support vector machines, doesn't matter, they all have a bunch of parameters. What are the weights you need to calculate for the system? So you're going to multiply all your inputs by some weight and then feed that into some other part of the network. Those weights have to be learned. And if you have a brand new problem, you initialize the weights randomly. Hopefully none of the neurons have the same value. And then you work really hard, or you make them work really hard to try and find a solution. What are the best weights to map from input to output? And that can take a long process of computation through multiple epochs of training, and can take a lot of training data and stuff like that. Luxuries you don't always have in every problem.
So that's initializing?
So the initialization there is to set all of the initial weights to a random value, just so you kind of have a sparse, not very good solution that you can improve upon. If you initialize everything to the same value, like all zeros, for some technical reasons, it makes it really hard for the thing to converge or to train very well. So you just kind of initialize it randomly, and then you find your way.
Do people initialize multiple times?
I don't believe I've ever heard of anyone doing that. I'm sure someone's tried it. I don't believe it's a fruitful methodology. Because ideally, after you've started learning, yes, depending on where you started from, you're going to learn different things, but hopefully all paths lead to the best outcome, more or less.
So if something's wrong, you wouldn't try and restart it?
Well, if something's wrong, you give up and start over, sure. But that's more like a failure, and you'll have to make a change, right? So you maybe give up and say, I think I've got too many layers here, the vanishing gradient's kicking in, or I've got exploding gradients or whatever. You want to make some architectural change. Just restarting on the same thing, it's like running software that has a bug. If you don't fix the bug, you're going to encounter it again. The neat, novel idea of transfer learning is just that you train first on some adjacent data set, then you either lop off your last layer of neurons and put some new ones in to learn the new problem from a better starting point, or you maybe mix in and now start training at the last epochs on the focus data you have. If you didn't do that, you might overfit the data or never converge to a useful answer. But in a lot of cases, and image analysis is one of the best examples, much of what the networks learn at the earliest layers are just edge detection and things like that are very universal or highly generalized. And it finds a way to look at just the right data manifold pretty effectively, then that can be a head start way to learn a different problem with not that much data.
That's all great. Thanks for explaining that, but what does it have to do with the important thing, Yoshi?
Yeah, well, I was trying to emphasize the point with Yoshi that, she learned to effectively land very well with only a few examples. So she's relying on other skills she has to transfer that knowledge. Machine learning takes lots of examples, or sort of the traditional out-of-box approach to machine learning. So as we tackle harder and harder problems, this will become more and more of a methodology that's important to data science and to AI. In fact, I'm quite sure there'll come a day within my lifetime where there are just some famous pre-trained sets that you just start from on most problems.
So going back to Yoshi, why do you think 10 landings is not that much?
Because the complexity of a landing, when you think about it, there must be 25 muscles involved in that at least, and the coordination of all those muscles, and figuring out kind of the mechanics of it. Like, she doesn't do Newtonian mechanics in her head, but they're at work. She's experiencing gravity and momentum and all these things, and she's got to kind of build up a way of learning all those interactions, and then finally attune the actuators of her muscular system to precisely implemented exactly the right motions to land safely and smoothly. That's quite an orchestrated project. We don't think of it that way because it's so automatic, but it is.
Yeah, I think that just speaks to how good she is. She's such a smart bird.
Yes, and biological machines do have this advantage that we come pretty pre-trained with a lot of stuff. Machines don't yet have that advantage, but transfer learning may be one way that they get it.
Well, do you want to tell the audience about her cute landing last night?
Oh, I think we'll save that for another episode.
Oh, okay. Next time.
Thanks for, you're going to still be on this ride for a couple hours, but we'll sign off. Thanks for joining me, Linda.
Thank you, Kyle. Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.